Good morning, students. Today is your mathematics class for chapter 2, class 9th, chapter name polynomial, lecture 3. Yesterday we discussed about remainder theorem and took one example also how we will start or work with remainder theorem. So today I took one more example of your exercise 2.3 related to your remainder theorem. So first of all, this is your question that x minus 1 by 2 is divide this polynomial. Now the question is how we will derive, because yesterday we took a very simple example that was x plus 1. So first of all, like yesterday, we have to take x cube here for the cancellation. So by what number we should multiply this x to get x cube? So another, like yesterday, we will follow the same method, that by what number we should multiply this x, so get x cube, and the another we will shift this x to this side to the other side, then it will present on division, then it becomes x square. So we should multiply it with x square. So we multiply x square with the both term, first with x, then we will get plus x cube, then minus 1 upon 2, then we get minus 1 upon 2 x square. Sign, next step, sign change, and then plus minus minus 0, plus 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 3 plus 1 upon 2 is 7 by 2, and we will take x square as common. Again the remaining part of the question, then we will multiply by x by 2 of x. How I know x by 2 of x? Then by what number we should multiply x, so get x by 2 x square. So I will get this x with this x, so 7 by 2 x. So we will follow this question like this and get our answer. So it is possible to solve so many different type of questions with the remainder theorem. So now students, we will switch on our next theorem, remainder theorem. Before remainder theorem, I took one more question from your exercise, that check whether one polynomial 7 plus 3x is a factor of 3x cube plus 7x or not. So we divide this polynomial by this polynomial to proving that it is a factor of this polynomial or not. So here we have 7 plus 3x, and then here we wrote dividend. Now some of the students are thinking, then what mom did, 7 is also here, 7 is also here. Question was 7 plus 3x. So most of the students are not comfortable with solve this question taking a constant number in the front of a variable. So I shift this 7, because we know it very well, here we have plus, so I shift this plus 7 to after of the remainder. So it will not affect the question, it will not affect the answer. So now I divide this polynomial with 3x plus 7 only. So first of all, like our previous two questions, by what number we should multiply, and then 3x to get 3x cube. So we should multiply with x square. So we multiply 3x square with, and then we get 3x cube, and then x square multiply with plus 7, then plus 7x square. Next step is sign change, it will cancel out, then plus minus minus. But it is not possible to solve these two terms, because here we have variable x square and here we have variable only x. These two different type of variables are not solved with each other, they both are different type of variables, different type of terms. So we will take both of the terms here, we can't solve them, because if we want to solve the question, then we solve x cube with x cube, x square with x square, x with x. So we will take both terms, minus 7x square plus 7x. Now the next question arises, by what number we should multiply 3x to get minus 7x square? So again I follow my method again, 3x multiply by what number to get minus 7x square, then we should shift this number here to the other side, and then it will be in division, then definitely it is minus 7 upon 3x. So I put minus 7 3 upon x here, and then I multiply minus 7 3 upon x with both terms. Then I get these two answers. Next step is sign change. It will cancel out. Then plus plus plus, I will take LCM of the constant number. Then I got 70 upon 3, and then x is common. Again I proceed with the same. Now I have a remainder where variable is not present, so we can't proceed this question without any variable. So it is proved that 7 plus 3x is not a factor of this polynomial. Now we will switch on your next topic, factor theorem. What is factor theorem? If px means a polynomial is a polynomial of degree greater than or equal to 1, it means again like your remainder theorem, it is not equal to 0 or less than 0, and a be any real number, then x minus a is a factor of px if pa is equals to 0. It means it's like only yesterday we learned how we will find the value of any polynomial. It's only like that. If px is a polynomial, एक px है which is greater than or equal to degree 1, जिसकी minimum degree 1 होनी चाहिए, and then greater than 1 is also possible, and a be any real number. a कोई भी एक real number है. Real number is the collection of all rational plus irrational. x minus a factor होगा px का when pa is equals to 0, and the another form of this theorem is if it is given that pa is equals to 0. If it is given in your question that pa is equals to 0, it is only possible when if x minus a is a factor of px. So if you can understand, these two terms are the vice versa to each other. If x minus a is a factor of px, it is only possible when pa is equals to 0. If pa is equals to 0 it is given, then x minus a is a factor of px. If this thing is given, then we will get this. If this thing is given, then we will get this. If these two things are given, then we will prove our question with these two conditions. Okay. Now we will take some questions based on factor theorem. So for verifying or learn about your factor theorem, I took exercise 2.4, and I am taking one question which is your first question of exercise 2.4. This is a part of first question. We have 4 parts in first question. I took only one. So if I want to prove x plus 1 is a factor of this polynomial or not, first of all I have to find the value of variable from the given polynomial. So x plus 1 is equals to 0. We learn in a factor theorem that if it is a factor, then the value of the variable should be equal to 0 in polynomial only. So what is the value of polynomial? When we put x plus 1 is equals to 0, then it is x is equals to minus 1, because when we will shift this number to the another side, it is sign change. So we will put this value of x in this polynomial. I put in all these value in this polynomial, and I get minus 1. So no, x plus 1 is not a factor of px, because you remember in our definition of factor theorem we read if x plus a is a factor of a polynomial px, then pa should be equal to 0. Now I took another example and a question, second question from your exercise. Then it is gx is x minus 3, px is given, and we are going to prove that gx is a factor of px or not. So again I will find a value of x from gx. So I put gx equal to 0, then x is plus 3. Then I put replace all variable of the given px with 3. Then I got 36 minus 36, which is 0. It means gx, when I put the value of variable from gx, then I got pa is equals to 0. So x minus 3 is a factor of px. So in one another question which is also present in this exercise, that find the value of k. Find the value of a k. It means any constant thing. Find the value of k if x minus 1 is a factor of px and kx square minus root 2x plus 1. is given polynomial. Now in this question we have to prove that we don't have any proof in this question. We only find the value of k. It is clearly given that x minus a is a factor of px. So by what number by what number we should find the value of k from the given px. Now it is given it is a factor. So definitely if it is a factor, then we will find the value of variable from this. So x minus 1 is equals to 0, then x is equals to 1. If x minus 1 is a factor of px, then definitely according to the theorem statement, p1 is equal to 0. p1 is equal to 0. Now I replacing the variable in the given polynomial with 1. I put all over the question x replaced with 1. Now I got this. We know it variable. If x minus 1 is a factor of px, then p1 is equals to 0. So the value of k is minus root 2 minus 1 is equals to k. So now student, it is your different type of question. Now I took another type of question, which is factorization, which we will do with the help of middle term splitting. So in another question we will do middle term splitting for factorization. We know it very well. First of all, we learn how many factors will be possible for this polynomial. So the highest power of the variable is 2. It means degree of the polynomial is 2. So only 2 maximum factors is possible in this question. First of all, we should multiply the coefficient of x square and the constant number with sign. So I got plus 12 and the middle term is minus 7. So we should make 2 factors like this whose multiplication is plus 12 and addition or subtraction is minus 7. So I took minus 4 and minus 3. If I will multiply these 2 terms, then answer is plus 12. If I add them, then answer is minus 7. So minus 7 is break into the 2 parts, minus 4x minus 3x. So I took a common from these 2 terms, 4x, then the remaining thing is 3x minus 1, and then I took minus 1 from here, then 3x minus 1. If I take 3x minus 1 as a common, then 4x minus 1 is a remaining part. This is our middle term splitting. It is only possible when we will get the correct multiplication part here and the correct middle one part here, and also to take correct numbers with sign to satisfy the condition. If multiplication get this number and addition or subtraction get this number. We will take another example in our next lecture. So today's homework is do questions of exercise 2.4 NCERT. Thank you.